Hello, and today we'll be discussing pyruvate decarboxylation. We'll get into what this process actually accomplishes. We'll go over the pyruvate dehydrogenase complex itself. We'll go over a couple of key components of this entire process, and then we'll get into each step that eventually leads us to a final product that's required to take part in the citric acid cycle. So the net equation for this entire process, or the whole goal of this process, is to prepare pyruvate to enter the citric acid cycle. And that can only be done by transforming pyruvate with the help of the pyruvate dehydrogenase complex into acetyl-CoA. Once this is accomplished, we can then begin the citric acid cycle. So as you can see up here, I wrote out this equation here to sum it all up. So pyruvate with the combination of some coenzymes will eventually yield acetyl-CoA and byproducts including carbon dioxide and NADH. So the complex itself is made up of three enzymes: pyruvate dehydrogenase, dihydrolipoyl transacetylase, and dihydrolipoyl dehydrogenase. These can also be referred to as E1, E2, and E3. And so our first enzyme here is what allows us to transform our pyruvate and transforms the acetyl component and prepares that to be used later in the reaction. Our second enzyme here, E2, allows us to finally take that acetyl component and transfer it over to one of our coenzymes. And finally, our E3 enzyme here is involved in the very last step of this entire process, and its job is to reform an important coenzyme so that we can continue this process and start it all over again. So now that we've gone over some of these enzymes, let's discuss the 5 coenzymes that take part in this entire process. So we have thiamine pyrophosphate, or TPP, and this is a prosthetic group that's attached to this first enzyme here. And so with the combination of these two, that gets the first couple of steps going in the process. Next is our lipoic acid, or a derivative of that, which is lipoamide, which is used for this process. Next, we have FAD, our CoA, and our NAD. So our CoA coenzyme is our carrier for the acetyl group that's formed in the first couple of steps, and that allows us to carry that group and create this final product of acetyl-CoA so we can begin the citric acid cycle. And FAD and NAD are involved in the last couple of steps, allowing for the regeneration of our coenzymes. So in total, there's 4 steps. 3 of those actually create the acetyl-CoA, a product, and our fourth step allows us to regenerate our coenzyme lipoamide, or a derivative of our lipoic acid. So our first step involves a decarboxylation. Our second step involves an oxidation reduction reaction. Our third step is when we form acetyl-CoA itself. And our last step is the regeneration of our coenzyme, lipoamide. Okay, so I drew out the first three steps here, and we'll go over these steps, and we'll kind of take a look at where our coenzymes come into play and what products come of these. So our first step here involves our coenzyme TPP that we discussed earlier, and that's actually attached to the complex itself. Here we'll just show the TPP component. And so what this does is reacts with our pyruvate and releases this carbon dioxide component here. And with the help of two hydrogen ions, this TPP and this here in purple, which will eventually become part of our final product, forms this larger complex here, hydroxyethyl TPP complex. And I've color-coded these here so you can follow along and see where exactly our carbon dioxide product comes from, along with the acetyl component that will eventually lead us to our acetyl-CoA product. Our second step here involves a second coenzyme, our lipoic acid, or a derivative, lipoamide. And when this reacts with hydroxyethyl TPP complex, we create this acetyl lipomide. And here is where the acetyl group is now prepared to transfer over to our CoA enzyme. And these two steps that occur in the first part of this reaction are accomplished by our pyruvate dehydrogenase, or our E1 enzyme, as mentioned previously. After our hydroxyethyl TPP complex reacts with our lipoamide, we have a regeneration here of our coenzyme TPP, which can then be used again to react with more pyruvate that's generated to create more intermediates to keep the process in a continuous state. So our next step here, our third step, is where we introduce the coenzyme CoA, and this is a reaction that is completed by our E2 enzyme, or our dihydrolipotransacetylase, our E2. And so what this does is this takes our acetyl component here in purple and removes it from this group here, finally forming our acetyl-CoA. And so as you can see, it's the first three steps where our acetyl-CoA is generated. And this is done by our dehydrogenase. But one interesting point here is that unlike our first two steps here where our coenzyme TPP was reformed here, that's not the case for our lipoamide. Instead, we form this dihydrolipoamide. And this requires another step in itself to regenerate our lipoamide coenzyme so that we can use it again after we create our hydroxyethyl TPP complex. And that's where the fourth step in this entire process comes in. And so as you can see here in these first three steps, we've used our TPP coenzyme, our lipoic acid enzyme, and our CoA enzyme. And in the final steps, we'll see our FAD and NAD coenzymes used as well. So in our final step here, we take our dihydrolipoamide and we combine it with our FAD coenzyme, and this allows us to finally regenerate our lipoic acid coenzyme so it could be used again in earlier steps as described before. And here you can see this FAD grabs a hold of these two hydrogen ions and forms FADH2. And here is almost a substep within itself where NAD comes in, which is our last coenzyme to be used. And here's where we form our NADH. And finally, our FAD reformed here in our final step. Step 4. This is pyruvate decarboxylation with the use of our pyruvate dehydrogenase complex and our 5 coenzymes that allow us to prepare pyruvate into acetyl-CoA so that we can enter the citric acid cycle.